Hello, good morning, all of you. So, we'll start our lecture. Okay, so first, we'll revise our yesterday's things. So, please, anyone tell me what is the definition of database? Aishwarya Poddar, please unmute your mic and tell me the definition of database. Aishwarya? Am I audible to all? Students, please reply. Hello,
Yes, ma'am.
am I audible?
Yes, ma'am. Audible.
Okay. So, please tell me what is database? So I don't want exact definition of database. So I want just whatever you understood. So what is database? Who will answer?
Collection of organized information.
Yes. Collection of,
Organized information.
organized collection. It is not collection of organized because it is the collection of data and then we organized that data in a well manner. Okay, good, Pratik. Then next, what are the different applications of database? Applications of database. Any application that you remember or other than the list that we have covered yesterday?
Banking, airlines.
Okay, banking. So how database is used in the banking? So to store what information we are using database in the banking?
Transactions.
Yes, to record the transactions data. Then what else?
To store the account details, savings account, checking account.
Yes. And the main thing to store the information about the customer. Okay. So the basic information about that customer, we use the database in the banking. Okay, good. Then another example.
Airline.
University.
Okay, university, airline. Good. What
Bank.
else? Bank transaction. Okay.
Sales.
Other people. Okay, in the sales. Other people, please reply.
Manufacturing.
Manufacturing. Very good. Then,
Hospital.
yes, in the hospital also we are using database.
Human resources.
Human resources. Okay. Then what else?
Online shopping.
Online shopping. Very good.
Login forms.
Login forms.
Yes, to
But
store
where we are
password and
using, but where we are using that login form? Means
uh,
everywhere we are
every
using login form.
it's everywhere.
Yes. So we are using login form in every application. So it may be any online site or it may be any company profile. It may be what we can say hospital reservation. So anywhere we are using the login form. Okay. So the login form, it is the part of that application. Okay. That login form, we cannot say that it is the main application or it is the different application. Okay. So it is the part of the different applications. Okay, then more examples. Anywhere
Business.
we are using where?
Business.
Business, okay.
Telecom sector.
Telecom sector, very good. To keep information or tracking the phone calls, etc. Okay, then what else?
Library.
Library. Okay, very good. Okay, so these are the applications of the database where we are mainly use the database to store the data. Okay, then what the next point we have seen, that is the purpose of database. Okay, so what is the purpose of database or why there is a need of database? I think total seven points are there for the purpose of database. So at least tell me main points.
Data redundancy.
Data redundancy and inconsistency. Okay, very good. So data redundancy means what?
Duplication of data.
What?
Duplication of data.
Yes, good. Data redundancy is nothing but the duplication of data. Okay, and what is the data inconsistency? Data inconsistency. Okay, I will tell. So, data redundancy and the inconsistency. As we know, the redundant data is nothing but the duplication of data, means the same data is placed in many files. Okay, and if we change some data in one file, so these changes must be reflected in all other files. Means we have to copy the changes to all the other files. Okay, then there will not be any problem. But if we change some data in only one file and if we have not updated that data into the another files, means what, that data is not match with each other, so it is called as the inconsistency of the data. Okay, so this problem is occurs with the file system, means when we are storing our information or the data in the files. Okay, so it is the first disadvantage of the file system. Now what is the second disadvantage or the next
Difficulty
disadvantage?
in data accessing.
Yes, difficulty in accessing the data. Okay, so
Means we
why
have
there is a difficulty? Huh?
we have to write a new program to perform each and every new task.
Yes, very good. Okay, means whenever we are retrieving data, means whenever we are accessing the data, if the suitable program is available there, then there will not be any problem. But if that particular program is not available there, then we have to write the new program every time when the new feature or new task arrives. Okay, so writing new program every time, it is difficult task. So because of that, the data accessing is difficult. Now, what is the third disadvantage?
Security.
Security. Okay. So, what is that? Security means okay. Security means what? So, only the particular user. Suppose that user wants the access of data, only a part of data, then he should access only that part of the data. But in the file system, all the users can access all the data. Means if the some data is not even relevant to that person, then also he can access that data. Means what, there is no any security of the data, so anyone can access any data. So we need to implement some security mechanisms into our database. So we cannot implement the security mechanism in the file system, but we can implement it with the database by giving some authorization to the person or access method to the person. so that he can access only whatever he want from the database. Okay, very good. Then what is the next disadvantage?
It is time consuming.
Any disadvantage? Time consuming. How? How it is time consuming? Anisha? Can you explain me? Hello? Okay, time consuming, what? Prashant, please say again. Data isolation. Yes, data isolation, it is one of the disadvantage. So the data isolation means our data is scattered or it is divided on multiple files. So again, that data is stored with the help of different programming languages and with the help of different file formats. Okay, so whenever we are accessing that data, so it is difficult because the data stored, suppose the data is stored in one format and I'm accessing the data in another format, then there will be the problem for accessing the data. So the data isolation, it is the another disadvantage of the file system. Okay, and the Anisha, time consuming, it is not the disadvantage. Okay, so we can say that the time consuming, it is the part of that difficulty in accessing data. Okay, if the particular program, application program is not ready with us, then we have to write the new application program. So that time consuming, it is a part of the difficulty in accessing data. Okay, now what is the next disadvantage? I think we have covered now 4 disadvantage. So 3 are remaining. So what are that? I want answers from what?
Integrity problems.
Integrity. Yes, data integrity. Okay, so the integrity means, so we need to insert some constraints or some conditions into our database. Okay, so whenever we are inserting any data, so if some conditions are there, then we cannot insert the incorrect data. So always we insert the correct or the updated data. Okay, that is nothing but the integrity or the constraints. Okay, so the number of data. Hello.
Hello. Duplication of data.
Data duplication. Okay. So Sanskruti, can you explain?
If a single customer is having different accounts and if we want to make some changes, so we have to make that changes in each and every account. And sometimes due to some reasons it may not be possible to make that changes. So that's why.
Okay, good. That is the data duplication or data redundancy. Okay, that we have covered already. Okay, no problem. So the integrity, we are in the integrity problem. If in any application some conditions are there and that condition should implement whenever we are creating our database. Okay, for example, that we have seen the transaction example or the bank account example. So the balance of that account should be greater than 0, or we can say that the balance of the account should be greater than 100. Okay, or we can take any example. Suppose any site or let's consider the Facebook. Suppose I want to create one account in the Facebook, then my age should be greater than 16. Okay, so this age greater than 16 means what? It is one integrity constraint, or it is the condition that I have to implement whenever I'm creating the database, okay, or whenever I'm creating some program related to that. Okay, so the integrity constraints we need to implement at the time of database. So implement these constraints in the file system, it is again difficult. Means if I want to add any new constraint, or if I want to change the existing constraint, then it will create the problem. Okay, so that is the integrity problem. Now what is the next problem? Two are remaining.
Concurrent access.
Yes, concurrent access of the data. Okay, so the concurrent access means whenever the multiple users are accessing the same data, then there may be the problem with that data, or there may be the problem of the updation. So if the multiple users are reading the data, then there may not be any problem. But if the multiple users are updating the data or writing that data, then it will create the problem. Means it may possible that if one user is updating the data and the another user may see the old value of that data. Okay, but it should be the case that the another user must see the updated value of that data. Okay, so it is called as the concurrent access of the data. Okay, and what is the last disadvantage?
Atomicity.
Yes, very good. Atomicity problem. Okay, so the atomicity means what? Atomicity, it is either 0% or 100%. Okay, means either all the transaction will perform correctly or none of the transaction will perform. That is nothing but the atomicity problem. Okay, again, to ensure the atomicity in our file system, it is difficult, but we can implement the atomicity in the database with the help of some transaction properties. Okay, so these are the total 7 disadvantages of the file system, and that is nothing but they are the purpose of the data. Okay, now next we have seen some advantages of the database. Means the database system, it overcomes the disadvantages of the file system. So the database system is having the solution for all the file system disadvantages. Okay, so now tell me the advantages of the database system. Any 2-3 advantages? Who will tell me? Aparna Limburkar, please unmute your mic and tell me advantage of database.
Centralized security. एक second. Security.
Yes.
Security, integrity, shared data.
Yes.
Data independence, etc.
Yes. Data independence.
Centralized management.
Yes. Centralization of data. Very good. Centralization of data means data is stored at only a single place. Means centrally the database administrator can handle the data. Means for example, in our college, our whole college network is handled by our daddy sir. Okay, so we can say that the daddy sir is the administrator for whole network, and our whole network's data or our servers are situated at our NKN. So we can say that the NKN is the centralized store or the centralized database for our whole college. Okay, now So as there is a centralized control or the centralized management, means there is no any duplication of data because the data is stored at only one place. So there will be only one copy of that data. So there is not any duplication of the data. Then next one, the data sharing. So we can share the data with the multiple developers, with the multiple users, so that they can access the data. Now next is the integrity. So we can check our data whenever we are inserting the data, or we can add some conditions for the values of the data. Then the security. Okay, means that database administrator, he gives access to the different users, so that the user can access only his data. Means for example, so our email ID and the passwords, they are created by the dadaser. Okay, or suppose the dadaser has given this responsibility to someone else. Okay, consider our Muske sir. Okay, so the Muske sir will create our ID password, and as a user, we people are only able to see our email account. Okay, but the Muske sir is having access to all the account. If suppose any problem is there related to our email account, then we can contact to Muske sir, so he will resolve our issue. Means what? Dade sir has given some access to different people, so that the different people can perform their duties. Okay, so it is nothing but the security advantage. Now next is the data independence. Okay, independence means the data is not depend on the another, means the main structure or the format of data is not depend on the another. Suppose if we change one part or one structure of the data, then it will not affect the another part of the data. Okay, so these are the some advantages of the database system. Now we will see our next point, that is the view of data. Okay, so the view of data means what? So the database view is nothing but the system, our computer system, it hides certain details of how the data is stored and maintained. Okay, means as we know, in our database or in our system, we are storing our data. Okay, only these things we are knowing, but how the system is storing that data and how the system is maintaining that data, so this part is not knowing to us. Means what? The system hides these kinds of details from the users. Okay, so in the purpose of the database system is to provide the users with the abstract view of data. Means what? The system hides some details from the user. So in the view of data, or this view is nothing but the data abstraction. Okay, so there is a data abstraction. So the abstraction means what? Hiding some details. Okay, so the data abstraction is nothing but to hide the certain details of how the data is stored in the system and how the data is maintained. Okay, so we can say that the data abstraction is nothing but the hiding irrelevant details from the user. Means user is not able to know that how the data is stored in the system, then what data structure is used for storing the data. So these details are hidden from the user, and the system shows only the relevant details to the user. Okay, so as we know, the users of the database system, they are not computer trained user. Okay, means many of the users are they are not knowing the computer or the information or the language about the computer, but they are using the using system, or they are using some mobile devices, etc. So the developers, they hides the different complexity from the users through different levels of abstraction. Okay, suppose our parents. Okay, so they are using our mobile system, but they are not they don't have all the knowledge about the mobile system. They are just using any apps or the applications, means they are just entering their data, and they are able to only see whatever the results that application will give. So they are not computer trained user. So the developer, they hide some details from these kinds of user. Okay, again, so there are different three levels of abstraction. The first one is physical level, logical level, and next one is the view level. Okay, so the physical level, it is the lowest level of the abstraction. So in the physical level, or it describes how the data is actually stored in the system, and it also describes the data structures, then storage structure, and the access method used by the database. Okay, so the physical level, it is very lowest level or the basic level of the abstraction, and it describes how our data is stored in the system. Okay, so as we know, our data is stored in the system, means it is stored in some memory or it is stored in the disk. Okay, so whenever that data is stored in the memory, then it is stored in which format, means the size of the data, whether it is in the gigabytes or whether it is in the bytes or it is in the terabytes. So these details are hidden from the programmer, or even these details are hidden from the user also. Okay, suppose for storing the data, we are using different data structures, means suppose for storing the data, we are using the tables, or we are using the tree as a data structure, or as a graph. Okay, or even simple as a structure. So the physical level, it describes so what different data structures are used to store the data, but it hides these details from the user. Okay, so that is nothing but it describes the how the data is actually stored in the system, and how that data is accessed from the system. So it is about the physical level. Okay, and this physical level, it hides these storage details from the user. Okay, now the next level is the logical level, or it is also called as the conceptual level. So the conceptual level describes, or it is the next higher level, it describes what data is stored in the system. Okay, and what are the different relationship among those data. Okay, so the logical level describes what data is stored in the system and what is the relationship between that data. So here many programmers or the database administrators, they are working on the logical levels, and the database administrator, he decides what information to store in the database. Okay, so here the logical level describes what data to store in the database. Now the data means what? Okay, so we are storing the data. So what we are storing exactly in the database? So the data is nothing but the different fields, or how many fields we are going to store in the database. Then what are the different attributes of that database, and what are the different data types. Consider the student example. Okay, if I want to store the data related to the student, then I'm using the different fields of the student, like the student name, roll number of the student, address of the student, or we can say the marks of the student, and consider the division of the student. Okay, so these 5 are the attributes of the data. So I am storing my data with the help of these attributes. And then what are the different data types for each attribute? Suppose my attribute is the student name. So for the student name, I am using character as a data type. If my attribute is the student ID, then I am using integer or the numeric as a data type. Okay, if the attribute is the address, then again I am using the character as a data type. So the logical level, it describes what data is stored in the system. So the data, it is in the form of what are the different attributes and what are the data types of that attribute. Okay, so in the at the logical level, the programmers and the database administrator, they are working at the logical level. Okay, and the last higher level is the view level. So the view level, it is the highest level of the data abstraction, and the view level, it describes only the part of entire database. Okay, so the view level, it describes only part of the entire database. Means suppose, again the same example, student database. So I have stored information about the student in the form of student ID, student roll number, name of the student, address of the student, and marks of the student. But suppose, as a user, I want only the name of the student and roll number of the student. Means I want only two attributes from that whole data. Means what? That this view level, it describes only the part of the database. Means the database will show me only the name of the student and roll number of the student. So it is called as the some part of the database, some part of entire database. Okay, so in the view level, the application programs, they hide details of the data types from the user. Means at the view level, generally all the users are working, or all the users they use the view level. Means the in the view level, the user, he use only that application with the help of some GUI, that is graphical user interface. So the graphical user interface means if one application is there or one app is there, then user can use that app or interact with that app with the help of some text fields, or with the help of some different forms or the web pages, we can say. So these are the some graphical user interface, and through this interface only user can access the data. Means he is only knowing that yes, this is the application, and here I want to enter my name, and here I want to enter my roll number, so that it will store anywhere. Means user is only able to know that some part of that data. Means he is only able to know the that he want to insert only this detail. But what is the exactly data type of that attribute? Means what is the data type of that name? What is the data type of that roll number? Okay, so these details are hidden from the user. Okay, and again, how that data is going to store in the system. Means how much amount of memory is allocated to store that data. So all these details are hidden from the user. Okay, so the view level, it is the very highest level, and it describes only the part of the database. Okay, so there are total three levels of the abstraction. First one is the physical level. So the physical level describes how the data is stored. Okay, so you have to remember these key points. That is, for the physical level, the key point is the how the data is stored. Okay, so how is the key point. Next, for the logical level, the what is the key point, means what data is stored. And for the view level, the key point is the part of the database. Okay, so these three are the levels of the abstraction. The lowest level is the physical level, and the highest level is the view level. Okay, so it is the diagram for the levels of abstraction. So here the physical level is at the lowest place. So the key point for the physical level is, so what is the key point for physical level?
How?
How? Okay, how the data is stored. What is the key point for the logical level? What? And what is the key point for the view level?
Part.
Yes, part of the database. Okay, So it is the view of data. Now it is one example of the different views. Consider, suppose I have declared one structure in our C programming language. Okay, so that name of the structure is student structure, and the student structure is having the student roll number, student name, and the project ID of that student. Okay, and some size is allocated for each and every attribute. The data type of the student ID is integer, data type of the student name character, and the project ID is also integer. And suppose some 10 bytes memory is allocated to each and every fields or each and every attribute. So here the physical level it describes, as we know, our data is stored in the memory in the form of different blocks. Okay, so whatever size of data we have given to each and every attribute, so the summation of all size, okay, consider here 10 10 10 means total 30 bytes of memory is allocated for the student database or for the student data. Okay, so in the physical level, so these 30 bytes or our data is stored in different consecutive blocks of the memory. Okay, so these details are hidden from the user, means how that student ID is stored in which block or what is the address of that block. Okay, so these details are hidden from the user. So at the physical level, the storage structure, we can say the storage structure is described. Now at the logical level, that is our conceptual level, so we are describing what are the different attributes are there and what are the data types of each and every attribute, that is the logical level. And the view level, okay, so you can see here, so view 1 means suppose this user 1, he wants only the student ID of the student, so he can able to see only student ID. Okay, and he may not see the student name and project ID. Same as consider the view 2 means the user 2, so he can see only the student name. Okay, and again from these different users we are hiding, so what are the different data attributes are there and what are the different data types we are using for that attribute. Part of the view is the instances and the schema. Okay, so the data instance and the database schema, they are similar similar to the type of the variable and the values in the variable, values of the variable. Okay, so the instance is nothing but it is it is the collection of information which is stored in the database, means the information that we are storing in the database at a particular movement or at a particular time is called as the instance of the database. Okay, or we can say simply the instance is nothing but the actual content or the actual values of the variables of the database. It is called as the instance of the database, means we are storing values to the variables of the database, so that values are nothing but the instance of the database. Okay, now next is the schema of the database. So the schema of the database is nothing but the overall structure of the database or the overall design of the database is called as the database schema. Okay, so the database schema means what? The structure means what? So what are the different attributes we are using and what are the different data types of that attribute? It is nothing but the structure of the database. Again, take one example of the programming language. That is database schema means what? So it is related to the variable declaration, means we are declaring the variables. Consider a variable a, and that variable is having the type definition, means we are defining the data type of that variable. Consider the int a. So this int a is nothing but the structure of the data. Okay, so in our case, or in the database language, we call it as a schema of the database. Now the instance, suppose we are giving some value to that variable. Consider 2. Okay, so the 2 is the value of the variable a. So this 2 is nothing but the instance of the database. Okay, understood? So the schema means what? It is the structure or the design of the database, and the instance means what? It is the actual value of the variable stored in the database. Okay, now there are three database schema. The first one is the logical schema, physical schema, and the sub schema. So the logical schema means what? The overall logical structure of the database at the logical level. Okay, so the logical structure of the database means what? Again, whatever attributes or the variables we are using, data type of that variable, size of that variable, etc. That is nothing but the logical structure of the database. And this structure is, we are defining this structure at the logical level. So it is called as the logical schema. Okay, then for example, the logical schema, the database consists of the information about the set of customer and the accounts in the bank and the relationship between them. Okay, means in that database we are storing the information about the customer. Again, for storing information about the customer, we are using name of the customer, ID of the customer, address of the customer, and account type of that customer. And we are using the information about the accounts, account number, then type of the account, okay, branch of that bank, etc. So the relationship between these two data is we can show in the logical schema. Then next one is the physical schema. So the physical schema means what? The overall physical structure of the database at the physical level. It is called as the physical schema. Means we are defining the storage structure. Okay, so that is nothing but the physical structure of the database, and it is present at the physical level. So it is called as the physical schema. Now next one is the sub schema. So the sub schema is nothing but the several schemas or the number of schemas which are present at the view level. It is called as the sub schema. So the several schemas are nothing but the different views of the database. As we know, there are multiple parts of the entire database. Means what? There are multiple views or multiple schemas of that database. Okay, and these schemas are present at the view level, so we can call it as a sub schema. Understood? So there are total 3 database schemas. First is the logical schema, second one is the physical schema, and the third one is the sub schema. Logical schema means what? The logical structure at the logical level. Physical schema means what? Physical structure at the physical level. And the sub schema means what? The several schema at the view level. Okay, so these 3 are the schemas of the database. And what is the schema? So the schema is nothing but the structure or the design of the database. Okay, so before creating the actual database or before inserting the value into the database, first we have to create the schema of the database. And once we have created the schema of the database, then we can create the instances of the database. Okay, so did you understood? the schema and the instance means what? Schema means the structure of the database, and the instance means what? The value of the value of every attribute in the database. So these values we are storing into our system at a particular moment of time. Okay, so it is called as the instance of the database. Then again, in the same point, that is in the instances and schema, one point is data independence. Okay, as we know, the data independence, it is the advantage of the database system. So the data independence is nothing but the ability to modify the schema definition in one level without affecting the schema definition in the next higher level. It is called as the data independence. Okay, so means the modification of schema definition means if we modify the schema definition at the logical level, then it will not affect to the physical level, or if we modify the schema definition at the physical level, then it will not affect at the logical level. It is called as the data independence. Now, in the data independence, there is a physical data independence. So the physical data independence means what? The ability to modify the physical schema without changing the logical schema. Means we can change the storage structure of that database without affecting the design of that database. It is called as a physical data independence. Okay, then in the physical data independence, the applications, they are depend on the logical schema, obviously. So in the logical level also, in the logical level itself, we can define the structure of the database, the design of the database. So the applications, they are depend on the logical schema. So in the physical data independence, we can change, we can modify the physical schema without affecting the logical schema. Okay, now in the view of the data, the next sub point is the data models. Okay, so the data models means there are different models available, and we can choose any of the model to perform the design of the database. Okay, so I think there are four data model. So we can choose any of the data model depending on the type of our data. So the data model is nothing but it is the collection of tool for describing data. Means what is exactly data? Data means the student ID, student roll number, student name, etc. Okay, so it is the collection of the tool for describing the data. Then data relationships means there is a relationship between student roll number and student name. Okay, means we can say that roll number 2 is of this student, means there is a relationship between the data. Then the data models are used to describe the use of data, means why we are using this data or where this data is used, that is the data semantics. And it also describes the data constraints, means the data conditions. Obviously there must be some condition on the data while we are inserting that data. Okay, so the data model, it describes all these things. First, the data model describes what is the data, then what are different relationship between the data, then what are the data semantics, means where we can use that data, and the data constraints on the data. So to describe the design of the database at 3 different levels, that is physical, logical, and the view level, we can use the data models. So there are 4 to 5 data models are available here, or we can use any of the data model. So very first is the relational data model. So the relational data model, it is nothing but it is the collection of the tables to represent the data and the relationship between the data. Okay, relational model, it is nothing but it is the collection of tables to represent the data and relationship between the data. Means in the relational model, we can store our data in the form of tables. Okay, as we know, the table is having the columns and the rows. So the table has the multiple columns, means a single table contains multiple columns, and every column is having the different name or the unique name, and the table is also having the rows for each of the column. Okay, so in the relational model, the table is called as the relation. Okay, so relational model, it is the part of the record based model. So in the record based model, again we are storing the data into the relation. That is nothing but we are storing the data into the tables. Okay, so in the relation or in the table, multiple columns are there with the unique name to each and every column. So these columns are called as the attributes in our database language. Okay, columns are nothing but the attributes, and the row of the column or the row of the table, it is called as the value of that attribute. Okay, understood. So in the relational model, we can use the table to store the data, and every table is having multiple columns and multiple rows for that table. So it is the example of the relational model. So in the relational model, all our data is stored in different tables. Okay, means we can use one table to store one data, another table to store another data. Means here is the example of instructor table or the teacher table. Means we can use the one table to store the information about the instructor, then we can use another table to store the information about the student. Okay, and this instructor table is having total 4 columns. Okay, so these columns are ID, name, department name, and the salary. So these columns are called as the attributes of the database, and every column is having multiple rows, and these rows are nothing but the value of the database or value of the attributes. For the ID attribute, these are the multiple values, or we can say that these are the instances of this attribute. Understood? Okay, if we consider the salary attribute, then 95,000 is the instance of the salary attribute, and the ID, name, department name, and the salary, and the data type of all these 4 attributes, it is nothing but the schema of the database. Okay, so in the relational model, we can store our data in the form of tables. Okay, so the next data model is the entity relationship data model. Entity relationship data model, or we simply call it as the ER model. Okay, so ER model, it uses the collection of objects, okay, to represent the data. So the collection of objects, it is called as the entity of the data, and it also represents the relationship among these objects. Okay, basically ER model, it is used to represent, or it is called as the collection of different objects, and these objects are called as the entity of the data, and it also represents the relationship between different entities. Okay, so simply entity is nothing but it is anything, or it is the object in the real world that is different from the other object. Means what? The simple example of the entity is nothing but the instructor or the teacher. Okay, so teacher, it is the one entity, or the teacher, it is the one object, and this object is different from the student object. Okay, so whether teacher and student, these two are same? Obviously no. So the entity means what? It represents the object in the real world, and every object is different from the another object. And the ER model, it also shows the relationship between the entities. Okay, so what is the relationship between the entity? Means what? The teacher means every teacher teaches to the student. Okay, every teacher teaches to the student. So this teaches is nothing but the relationship between the student and the teacher. Okay, so there must be some relation between two different entities that we are using in our database. So mainly the ER model or the entity relationship model, it is used to design the database. Okay, now the third model is the object based data model. So the object based data model, we can say that it is the extension of ER model. Okay, means the object based data model contains all the features of the ER model, or all the symbols of the ER model, plus it is the extension, means plus it is also having its own symbols. So object based data models, it uses all the object oriented concepts. Okay, means it represents all the object oriented concepts like the inheritance, arrays, structure, function, method, generalization, specialization. Okay, so all these are the object oriented concepts, and we can represent it with the help of object based data models. Object based data model are nothing but it is a combination of the object oriented model and the object relational model. Means the object oriented concepts are implemented in the relational model, so it is called as the object based data model. Okay, object based data model, it is the extension of the ER model, or it extending the ER model, and it also represents some additional features of the object oriented concept. Now the fourth data model is the semi-structured data model. So the semi-structured data model means the structure is not fixed for these kinds of model. Okay, as we have seen the relational model. In that relational model, we are using the tables. So in the ER models, we are using different entities to represent the data. So in the semi-structured model, the structure is not fixed to represent the data. So we cannot differentiate between the actual data and the design of that data in this model. Okay, so it is called as the semi-structured model. Means we cannot differentiate between what is exactly data and what is exactly the structure or the schema of that data. So this thing we cannot differentiate. For example, we are using a number of websites. Okay, so if we have clicked on any of the web page, then it shows us or it gives us number of options. So in that option, one option is view source code. So if we click on that view source code, then we cannot differentiate between what is the exactly data and what is exactly the design of the database. So every web page is developed with the help of either PHP or the HTML, etc. So it will show the source code of that HTML or the whatever PHP. So that data is stored in the form of semi-structured data, or that data is called as the semi-structured data. So we cannot differentiate from that what is exactly data and what is the design of that data. Okay, so it is the semi-structured model. So in the data model, there are total 4 data models. First one is the relational model. So in the relational model, we store the data in the form of tables. Second one is the entity relationship model. So in this, we can represent the data with the help of different entities and the relationship between the entities. And the ER diagram, it is the what we can say, this diagram contains different symbols to represent the database design. Now next is the object based data model. So in the object based data model, we can represent the object oriented concepts, and in the last one is the semi structured data model. So in the semi structured data model, we can represent the combination of the data and the schema. Okay, that is generally the XML is nothing but the semi-structured data model. Means in the XML we can store data, so it is in the form of semi-structured data model. Now we'll see the next point of our chapter, that is database languages. Okay, as we know, to create any kind of database, we must know some language or some syntax are there to create the data. Consider the case of your programming language. It may be C, C++, Java, or .NET, etc. So for creating any application using the Java, or for creating any application using the C++, so there must be a particular format to create that application. Okay, means we are taking the class, then we are declaring different variables, we are allocating values to the variables, sometimes we are allocating memory to that variable, we are using array, etc., etc. So that is the case of the programming language. But in the database, if we want to create the data, if we want to insert, give some values to the data, then we must know the database languages. So there are two parts of the database language. Okay, so the mainly our main language is the SQL, that is structured query language, and the data manipulation language and the data definition language. These two are the part of this structured query language. So whenever we are creating our data, we can use the SQL language, okay, to create the data. So SQL, it is the language, and we have to we have to install this SQL server or the SQL language into our machine, so that we can perform the practicals, or we can use the data manipulation and the data definition language. So there are two parts of the database language. The first language is the data manipulation language, that is DML, and the another one is data definition language, that is DDL. So first we'll see data manipulation language. So the data manipulation language means this language, it is used for accessing the data and manipulating the data organized by the appropriate data model. Means we are using any of the data model for designing purpose, and we are using the DML language for accessing the data and for manipulating that data, which is organized by the any data model. So we are accessing the data. Accessing means what? We are retrieving the data, means we are using that data. So there are different types of the data accessing, data access. The first one is the retrieval of the information. So in the retrieval of information, we retrieve the information which is stored in the database. Means we get that information which is stored in the database. Another is insertion of the information. So we can insert the new information into the database. Means consider we have created the student database, and some values or some rows are already present in the student database, and I want to add the record of the roll number 10. Consider, okay, I want to add the record of the roll number 10. So I can insert this new information into the existing database. That is nothing but the insertion of the information. Next one is the deletion of the information. Means we can delete some information which is already exist in the database. Suppose I want to delete the roll number 5. So I can delete the record of roll number 5 from that from my database. And next one is the modification of the information. So the modification of information means we change something in our database. Means the modification of the information which is stored in the database. Suppose I want to modify the address of roll number 10. Okay, currently the address of roll number 10 is Solapur, and after modification, or I want to modify that address from Solapur to Pandharpur. So I can modify that data also. So the DML, that is data manipulation language, it allows us to access the data, then it allows us to manipulate the data. Again, the data manipulation is nothing but the modification of the data. Means we are updating some data. That is nothing but the data manipulation. So whenever we are retrieving the data, means whatever data is currently present in our database, so all that data we can retrieve. Or if I want only the roll number of all the students, then I can retrieve only roll number of the students. Means without changing any data, I am retrieving the data as it is. But whenever we are inserting the data, we are deleting the data and we are modifying the data. Means we are updating that data or we are manipulating that data. Okay, data manipulation is nothing but the data modification. Means whenever I am inserting the new data, means I am modifying my old data. Suppose my old data contains only 10 rows, and after insertion of the new data, my data contains 11 rows. Means what? I have updated my data. Suppose I am deleting some data, I am deleting some value from that data. Again, I am updating my data. Or if I am modifying the data, means what? Again, if I am changing the name of the student, or if I am changing the address of the student, means what? The modification of data. So these three parts, that is insertion, deletion and the modification, they are nothing but the manipulating data. And the retrieval of data or the retrieval of information is nothing but the accessing the data. Okay, so the data manipulation language, that is DML, it describes or it provides us the accessing data or the retrieving data, and also it provides to manipulate the data stored in the database. Okay, then the DML is also known as the query language. Okay, so we have seen the structured query language. So what is exactly query means? So the query means what? It is the statement or the set of statements or the sequence of statements which are used to retrieve data from the database. Okay, so the query means what? These are the statements, and while after writing this statement, we can retrieve the data from the database. That is nothing but the query. And every time whenever we are performing any kind of operation into the database, means what? We are writing the different queries to the database. Suppose if I want to insert new record into the database, means I am writing the data insertion query. Okay, so whatever statements we will write in the in this DML or in the database, so that statements are called as the query of the database. Okay, so there are two classes of the DML language or the DML. The first one is the procedural DML, and next one is the non-procedural or the declarative DML. Okay, so the procedural DML, as the name suggests, procedural means it provide a particular procedure. Okay, but procedure for what? So the procedural DML, it specifies what data is needed and how to get those data. Okay, procedural DML means what? What data is needed, means what data I want, or uh, which data I want to retrieve. That is nothing but the what data needed and how to get those data. Means I know how to get that data. So by writing a particular query, I can retrieve that data. Means I am providing a procedure for retrieving the data. So the procedural DML is nothing but it describes what data is needed and how to get or how to retrieve that data. So example of the procedural DML is the relational data or the relational database. And another type of the DML is the non-procedural or the declarative DML. So it only specifies what data is needed without specifying how to get those data. Okay, so the non-procedural means there is no any procedure to retrieve the data. We simply say that I want this data, so it will give me that data. But how to retrieve that data, how to get that data, it will not specify. And the example of non-procedural DML is tuple and the domain relational calculus. So we'll see these two examples in our second chapter. Okay, so have you understood the first part of the database language, that is the DML, data manipulation language. Okay, data manipulation language, as the name suggests, it is the manipulation, means we can retrieve data as well as we can manipulate the data, means we can modify or we can change the data. That is nothing but data manipulation language. Okay, now the second one or the second type is the data definition language, that is DDL. Okay, so the data definition language, so in this we specify the database schema by a set of definitions expressed by the DDL. Means the DDL, it specifies the definition, the schema of the database. Means with the help of DDL statements, we can create the schema of our database or the design of our database. As we know, schema means what? Schema is nothing but the different variables and the type of the variables. Okay, so in the database also, first we have to create the schema and then only we can insert values to the data. Okay, so it is the one example for the schema definition. So here the create table instructor. Okay, means I am creating one table. Okay, that name of that table is the instructor, and here in bracket ID, name, department name, salary. Okay, so these are the attributes of the instructor table, and these are, that is character, varchar, numeric, these are the data types of this attribute. Okay, so the DDL, it is basically used for creating the structure of the database, then creating the structure of the table, creating the indices and the other objects. Okay, then the DDL, it is used to alter the structure of existing database, then delete or drop the object from the database and remove all the records from the table, including all the spaces allocated for the records. Okay, so with the help of DDL, we can just create the structure of the table. We can just create the structure of the database. We can create the index used in the database. Okay, and here also, if I want to modify the structure of the table, means if in this instructor table, suppose I want to change the name of this ID attribute, and after updation or after changing, the new name of this attribute is the instructor ID. Okay, means I need to give the instructor ID attribute to this ID attribute. Means I want to rename this attribute. Then I can perform with the help of alteration of the structure of database. Okay, so it is called as the data alteration. Alteration means again we are changing, we are updating something. So if we want to change the structure of the database, then we can use the we call it as a alteration of the database. Then if I want to delete this name attribute from this table, then I can use the delete or the drop object from the database. Means if I want to delete any attribute from the table, then I can use the delete that attribute. And it also removes all the records from the table. Means if we use one command, that is the command is called as the truncate. So that truncate command will remove all the attributes, all the information from that table, and even the memory spaces they are also removed. Okay, memory spaces allocated for the records, they are also removed from the database. Okay, so the data definition language, that is DDL, it is mainly used to define the database schema and the database structure. Okay, understood. There is a difference between DDL and DML. So generally we are using DML for handling the values of the table or for handling the rows of the table. Okay, in simple language, the DML, it is used to manipulating or handling the rows of the table, and the DDL, it is used to handling the columns of the table. Okay, so before creating the table, first we need to create the database for that table. Okay, so there must be only single database, and in a single database we can use multiple tables. Okay, so it is not necessary that if I have used the student database, and in that student database I am using only the student record table. Okay, and if I want to use the teacher table, okay, then I have to create the teacher database. No, it is not the case. If I have created one database, that is the student database, the student database, it contains all the information about that student, and the teachers are also required. So we can also include the teacher table into the student database. Okay, so have you understood the DDL and the DML? Because these two are very important as a practical point of view. Means if these 2 points you understood, then we can perform the practical very easily. Okay, so data manipulation and the data definition. Okay, data definition means whatever we define or whatever structure we define for the data, so we handle that structure with the help of data definition language. And data manipulation language means what? So whatever values we are inserting to the database, so we handle that values. Okay, that is nothing but the data manipulation language. And again, the DML, in the DML, we are retrieving the data, we are inserting new information into the data, we are modifying the data, and we can deleting the existing data. Okay, so these four, we can say these 4 points or these 4 commands we can use in the DML. And in the DDL, we can create, first thing or the first command is the creation of the database, creation of the table, creation of the indexes, etc. Then if I want to change the attribute of the table, then I can use the alter command or alter the structure of the existing database. Okay, and we can, in the DDL, we can also use the deletion of the attribute, or we can also use we can also remove all the records from the table, including the space allocated for the table. Okay, so have you understood the 2 parts of the SQL languages? First is the DDL and another one is the DML. Okay, now next one is, so whenever we are using the DDL, so that DDL compiler means whenever we are writing the query for creation of the database or creation of the table, then that after execution of that query, the DDL compiler, it generates the set of tables. Okay, and these tables are stored in the data dictionary. So when we compile and when we execute our DDL statements or the DDL queries, then whatever result is created, so that result is nothing but the table or the output of every DDL query or the output of every DML query. It is the table only. So whenever we are executing the DDL statements, to whatever result is created, that is in the form of table. So this table is stored in the data dictionary. So the data dictionary is nothing but the or it contains the metadata. Metadata means the data about the data. So data about data means what again? Suppose that we have created the table of the instructor and we have executed that statement. So it will return one table. So that table contains, okay, so that table contains first ID attribute, then in the second column is the data type, that is the character, then third column is whether it is the primary key or not. Okay, means the key column. If it is the primary key, then in the data dictionary it will show here the primary key. Then if the value of this ID attribute is the null, means I don't want insert any value for the ID attribute, then it also show whether if I have given here the null, then it will show me the ID attribute is the null, means we cannot insert any value for this ID attribute. Okay, so this is nothing but the data about data. Okay, data about data means one data is already there, that is the attribute of the table and data type of the table. So in the data dictionary, it will also show me the attribute, data type, size of every attribute, then whether it is primary key or the foreign key, whether the values of this attribute are null or not. Okay, so it will show me another information also. So this information is called as the metadata, and this metadata is stored in the data dictionary. Okay, so the DDL provides some integrity constraints. Okay, as we have seen, the integrity constraints means some conditions that should be implemented in the database. Okay, so DDL provides total 4 integrity constraints. So very first is the domain constraint. Okay, so the domain constraint means what? The value of the what we can say, the domain of the possible values must be associated with every attribute. Okay, means the domain of every value must be associated with every attribute. As we know, we are inserting some values to the attributes. Consider the ID attribute. Suppose I have declared that ID attribute as a integer. Okay, so this integer is nothing but the domain of that ID attribute. Okay, simply this domain is nothing but the data type of that attribute. Means whenever I am inserting the new value to the database, and if the integer attribute integer data type is there, and if I am entering the integer value only, then there will not be any problem. But if I am entering the character value, means for the ID attribute, suppose I am entering the ABC as a input, then it will not insert that ABC value into the table, because our constraint is the domain constraint. Means if I have declared one attribute with one particular type, that is data type, then I can insert value of that data type only. So it is called as the domain constraint. So the value of the attribute must be available in corresponding domain. Means whatever value we are inserting, so that value of that attribute must be present in that domain. Suppose I have declared one attribute as the character attribute, then only I can insert the character value, means name of that student. So that I can only insert the ABC, XYZ or any name, whatever we want. But here we cannot insert the numeric value, okay, or we cannot insert any special character. That is nothing but the domain constraints, okay. So it is the first integrity constraint of the DDL. So domain is nothing but it is we can say the simply the data type of the attribute. So whenever we are declaring attribute to be a particular domain, then it itself act as a constraint on the values of that attribute that we are inserting. Okay, means if we declare a particular attribute as a particular domain, then this is nothing but one condition for that attribute or one constraint on that attribute. Means if I have declared the attribute as an integer type, or if I have declared the attribute as a date and time type, then I can only insert the date and time in the particular format. Or if I have declared in a character, then I can only insert the character values to that variable. I cannot insert the integer values. Okay, so it is the domain constraints, or it is a one condition on the values of the attribute. Then the second one is the referential integrity. Okay, referential integrity means what? So there are some cases where we want to ensure that the value that appear in one relation for a given set of attributes. Okay, please listen carefully. The value that appear in a relation, or the value that present in the relation for a specific attribute, so it also appears in another relation for the another set of attribute. Okay, means suppose we want the value of one attribute which is present in one relation, and if I want the same value in another relation for the same attribute, then I can do it with the help of referential integrity. Okay, means if the value of the one attribute of the relation references a value of the another attribute, then the referenced value exists there. Okay, means we can give reference to the another attribute. Let's take one example. That is, consider there are two relations. Okay, first relation is the department relation, and another relation is the course relation, or two tables, department table and the course table. And the department name value in the course relation must appear in the department name attribute of the department relation. Means what? Here there are two different tables or two different relations, department and another one is the course, and these both relations, they are having the department name as a one attribute. So whatever value or some values of the department name of the course relation, so all these values must be present in the department name attribute of the department relation. If such cases are there, then we can say that these values are referenced values, and it is called as the referential integrity. Okay, means consider in the department table, consider the computer, electronics, mechanical, electrical, these are the some departments. And in the course table, suppose the department attribute is also there, and some another attributes are also there. So I can say that the particular instructor or the particular teacher who works in the computer department, but he teaches to the electronics department. Means it may possible that, so if such cases are there, then we can reference the values. Okay, so for this purpose we require the referential integrity. Okay, so the referential integrity is nothing but the value of the attribute in one relation also appears in the value of the attribute of the another relation. Then it is called as the referential integrity. Okay, so these types of integrity also we can implement in our database with the help of some key concept, that is primary key, foreign key, etc. Now the third constraint is the assertion. So the assertion, it ensures a certain condition will always exist in the database. Okay, simply assertion means what? Any condition will always present in our database. So at that time we can use the assertion. So the basically the assertion it's created. Assertion it is created to test the validity of the data. Okay, especially we are using assertion to test some data validity. And the assertion it is like some column level and some table constraints. Means it is like our domain constraint also, and it is like our referential integrity constraint also. So assertion, simply remember that the assertion is nothing but any condition. Means we can check that condition into our database. Okay, again let's take example, that is every department must have at least 5 courses offered every semester. It is one condition. Means what? Every department is having minimum 5 courses or minimum 5 subjects for every semester. So if I am entering the data in that database, and if suppose in a single semester, suppose I have entered the 5 subjects, then it will not create me problem. Means minimum 5 should be there. But if for a single semester, if I have entered only 3 courses or only 3 subjects, means it will show me some message like that is nothing but the validity of the data. Means in the statement I have given that, so every department is having at least 5 courses or the minimum 5 courses. So the values of the courses must be minimum 5. Greater than 5 it is allowed, but less than 5 it is not allowed. So these types of assertions we can use whenever we are inserting the data or whenever we want any result from the data. Okay, means at the time of retrieval of data we can use the assertion. Means we can just give any condition to our data. Okay, and the last one, it is the authorization, or the last constraint is the authorization. So the authorization means suppose if we want to differentiate among the users of the database based on the type of the access they are allowed on the data, then we can use the authorization. So simply authorization is nothing but who can access what data, that is nothing but the authorization. Means which user can access what kind of data is nothing but the authorization. So the database administrator, he gives these kinds of access or these kinds of authorization to different parts of the user or to different user. So these are the some types of the authorization. The first one is the read authorization. So the read authorization is nothing but the user can always read the data, but he cannot modify the data. That is nothing but the read authorization. Means we can give restriction on the view of data, or we can give restriction to access the data. That is nothing but the data authorization. Okay, then second one is the insert authorization. Insert authorization means the user can insert the new data but cannot modify the existing data. Okay, suppose in that table total 10 rows are already present, and if I want to insert the new row into that database, so I can insert that data, but I cannot change the data which is previously stored in the system. Okay, next one is the update authorization. So in the update authorization, it will allows me to update the data, means to modify the data but cannot delete the data. Means if some existing values are there, means the roll number 5, okay, name of that roll number 5 is considered ABC previously, and if the database administrator has given me the update authorization, then I can change the name of that roll number 5 from ABC to XYZ, but I cannot delete any data. That is nothing but the update authorization. And the last one is the delete authorization, means we can only delete the data. That is nothing but the delete authorization. Okay, so the database administrator may assign the user all the authorizations, or none of the authorization, or the combination of these types of the authorization. Means the database administrator can give me only the read authorization, or he can give me the read authorization as well as the insert authorization, or he can give me the combination of any of the authorization or none of the authorization. So it depends on the type of the user who accessing the data, and it depends on the database administrator. Okay, so like this way we can restrict the user to use the data. Okay, so we have seen total 4 integrity constraints that we are using in the DDL. Okay, the very first integrity constraint is the domain constraint. Okay, domain constraint means what? Domain constraint, it is nothing but we should insert a value of a particular domain only. Okay, so the domain or the data type of that attribute, it itself act as a constraint on the values of that attribute. Then the second one is the referential integrity. Suppose I want to use the information from the 2 tables or 2 or more tables, then there must be some referenced value present in both the tables. Okay, so the condition for that referenced value is that the value and the attribute name should be common in both the tables. Okay, that is nothing but the referential integrity. Then third one is the assertion. So the assertion means what? It is any kind of condition. So we cannot define such condition. So whatever the situations are there, or whatever the cases are there, so depending on the situation we can use the assertion. Means we can check the validity of our data, whether whatever data we have entered, so whether that data is valid or not, that we can check with the help of assertion. And the last one is the authorization. Okay, so authorization means we can give the access to different users, means who can use what, who can access what data. So there are 4 forms of authorization: read authorization, insert authorization, update authorization, and the delete authorization. Okay, have you understood the database languages? 2 types, DDL, DML. Okay, and in the DDL 4 integrity constraints that we have seen now. Okay, now the next one is the relational database. Okay, so in the relational database is nothing but it is based on the relational model. Okay, so the relational model means the table. In the relational model we can represent the data in the form of tables. Okay, So the relational database, it is based on the relational model, and it uses collection of tables to represent the data and the relationship between the data. Okay, so that is nothing but the relational databases. Now, whenever we are doing practicals, so at that time we are using this relational databases, means we are storing our data in the form of tables. Okay, so in the relational database, as we know, we are storing data in the form of tables. So every table is having the multiple columns, and every column is having the unique name. Okay, means the names of two columns should be different from each other. So in the relational database, the column is called as the attribute of the table, and the row is called as the value of the attribute, or if we consider the whole row of the table, then it acts as a relationship between the set of values. Okay, so it is the sample relational database. So there are two tables. Okay, instructor table, and the next one is the department table. Okay, so in the instructor table, ID, name, department name, salary. These are the attributes of the table, and these are the values of the table. Okay, if we consider only a single value, that is 95,000, means what? It is simply a value of the attribute salary. But if we consider the whole row, so this whole row is nothing but it shows the relationship between the set of values of the attribute. Means what? The ID is 222. Okay, and the name of that instructor is Einstein. Okay, and this instructor is from the physics department, and the salary of that instructor is 95,000. Means what? With the help of this single row, I can describe that instructor, means I can give some information about that instructor. Okay, so this row are nothing but, or the row is nothing but, it shows the relationship between the value of different attributes. Similarly, the department table, department name, building, and the budget, these are the attributes, and these are means the computer science, then tailor, and 1 lakh. Okay, so it is nothing but the value of these attributes, and it also show me the relationship between the value of the attribute. Okay, so it is for the relational database, and we can represent the relational database in the form of tables. So I think so can we continue for 2-3 minutes? Look, I think today we will stop here. Okay, we will see the remaining part of the relational database in our next lecture. Okay, so do you have any doubt? The concept we have covered up till now. Any doubt?